Okay, our last example in section 4, we have some more rational exponents, but some things that are a little bit more complicated. So here's example 4. And again, I'll do 2 examples here, and then I'll do 2 more examples in the B video. So my first one here, let's do 8x to the 15th power, all to the negative 1/3. Refocus that a little bit. Okay, the first thing I notice is that I have a negative exponent. And since I have a negative exponent here, and the rest of this is all positive, we don't have any negative exponents inside here, I'm going to start off knowing that my negative exponent is going to do something with the reciprocal. Then I have 8x to the 15th, all to the positive 1/3 power in the denominator. Now, if I have all of this stuff to the 1/3 power, I have to take the 8 to the 1/3 power, and I have to take the x to the 15th, all to the 1/3 power. So 8 to the 1/3 power. Now, if I have a power to a power, do you remember what to do with these? I want to multiply. So 15 times 1/3 gives me x to the 5th.
Minus or keep the exponents.
That was awesome. Okay. This 8 to the 1/3 power, well, let's think about what that means as a radical expression. 1/3 is the cube root of 8 times x to the 5th, and this works out pretty nicely because I could take the cube root of 8 and get 2x to the 5th in my denominator. So after all of that, we ended up not having a radical in the denominator and everything was okay. All right, my next one, I have 9x times the 4th root of y, all to the 3/2 power. Okay, there's a couple things I don't like here. And the biggest thing I don't like is that I have the 4th root of y, and then I'm going to have to take that to the 3/2 power. So before we do anything else, let's take this 4th root of y and write it as a rational exponent, which would be y to the 1/4. So 9xy to the 1/4, all to the 3/2 power. Again, each thing in here needs to go to that 3/2 power. I need to take 9 to the 3/2, x to the 3/2, y to the 1/4 times 3/2. Remember how to multiply fractions? We multiply the numerators and get 3. We multiply the denominators and get 8. Okay. Now there's one thing that I really don't like here. And the next thing that I really don't like is that if I change these back to radical expressions, I'd have a square root here, and then an 8th root. And we can't really simplify that. Ideally, I want to be able to write my final answer all as one root. Well, I can't really write 3/8 as something over 2. But I can write these as something over 8. 3/2 would be 12 over 8. Now this is nice because all of these are over 8. We can all write them as an 8th root. So we could write the 8th root of 9 to the 12th times the 8th root of x to the 12th times the 8th root of y to the 3rd. And actually, let me go back for a second, because really, instead of taking this 9 to the 3/2 and changing it to 9 to the 12 over 8, it really would have been better to write this as a radical right off the bat, because we can figure out what this number is. We should have really done, or I should have really done instead, the square root of 9 and then cubed it. The square root of 9 is 3, cubed is 27. That actually makes life a lot easier than what I had been doing before. So then the last little bit I can do, I have an 8th root and an 8th root. I have 27 times the 8th root of x to the 12th, y to the 3rd. And hopefully you're noticing, Mrs. Bishop, you actually can do something else. I have an x to the 12th underneath an 8th root. I can pull that out. You can pull an x out and have an x to the 4th underneath still. X to the 4th, y to the 3rd. Okay, one last thing we really need to think about. Do I need absolute value? Well, this 3/2 power, I had a square root, but I really had the square root of x to the 3rd. So if x was a negative number, then I'd have a negative under the square root. That's a problem. I don't need absolute value. We're good with that.